Hello everybody. Today we are going to talk about electrostatics and electricity. At first, I will explain about the vocabulary and the formula. Current is a stream of charged particles such as electrons moving through a conductive material or speck. Electrical currents are measured in amperes. Resistance is a measure of the opposition to the flow of the electric current. Resistance are measured in ohms. Potential difference is the difference in the amount of energy that charge carriers have between 2 points in a circuit. Potential difference is measured in volts and is also called voltage. The energy is transferred to the electrical components in a circuit when the charge carrier passes to them. We use a voltmeter to measure potential difference or voltage. Ammeters. An ammeter measures the flow of current that passes through it. Ammeters have to be connected in series in the same loop of the circuit with the electrical component whose current you are measuring. The potential difference, which is the same as voltage, is equal to the amount of current multiplied by resistance. The formula that current relates to charge and time is I equal Q over T, while I equal current in amperes, Q equals charge in coulombs, and T equals times in seconds. Ohm's law. It was found by George Simon Ohm. It states that the current through a conductor between 2 points is directly proportional to the voltage between 2 points and inversely proportional to the resistance between 2 points.
Okay, let's talk about Kirchhoff. They actually have two rules. The first rule, sometimes called the current rules, is also sometimes referred to as junction rules. The second rule is the voltage rule, sometimes referred to as the loop rules. Once start seeing what these rules are, you will find that there are connections between current and junction, voltage and loop. So for the current rules, it states that at any junction, the total current in equal to the total current out. Now, for example, if pick junction here, then the total current coming into that junction has to be equal to the sum of the current coming out from that junction. As you see on the diagram, there is I1, I2, and I3. This can make up an equation that is I1 equal to I2 plus I3. This could express all the current coming into the junction as positive value and the current coming out from the junction as negative value, in which case this total current has to be zero only. Now let's look at the voltage rules. For the voltage rule, allow any closed loop, the sum of the voltage equal to zero. Now another way to look at this is to remember that each voltage is a potential difference, so we could phrase this rule as around any closed loop, the potential return to its original value. Let's take a look at an example. This battery has potential increased to 10 volts. As move across this resistor, it might drop to 7 volts and then move across another battery where it has 5 volts. Finally, moving across the last resistor, it could have a minus 8 volts. Now this particular number will just kind of pick them, but I had to pick them in such a way that when I add up all of the increase and decrease across the entire loop, I came up with value of 0. What is power? Power is a rate at which energy is produced within a circuit, and the unit for measurement is called watt. For the formula, P is equal to I times V. P is power, I is current, V is voltage. By the formula, P equal IV. P is measured in joules per second. I is measured in coulomb per second. V is measured in joule per coulomb. Joules over second equal coulomb over second multiplied by joules per coulomb. After that, the coulomb got cancelled out, and it has left with P equal I times V. After that, phi V power 2 over R is from V equal IR, and rearrange them in form of I equal V over R and time V into V over R. The formula will come out as V power 2 over R. Resistivity is electrical resistance of a conductor of unit length. Resistivity useful for conduct material based on current flow. If the resistivity high, it makes sense that conductor will be poor. If A is increased, R will be decreased immediately. Or another way is to change material that have less conductor. The formula is R equal rho L over A. R is resistance measured in ohms. Rho is resistivity. L is length. A is area. Resistivity is electrical resistance of a conductor of unit length. Resistivity useful for conduct material based on current flow. If the resistivity high, it makes sense that conductor will be poor. If A is increased, R will be decreased immediately. Or another way is to change material that have less conductor. The formula is R equal rho L over A. R is resistance measured in ohms. Rho is resistivity. L is length. A is area. How to find resistance in the series circuit? In this circuit, there are 3 volts and every volt have 10 ohms. You just need to add up and use the formula RT equal first volt, next volt, and next volt. Just add up and you're gonna get RT equal the answer. Like this one, there are 3 volts and every volt have 10 ohms. You just do like RT equal 10 ohm plus 10 ohm plus 10 ohm. It's gonna get RT equal 30, and the 30 is the answer.
Now, let's see how we're going to find the resistance in parallel circuit. To calculate this, you need to use a formula 1 over resistance 1 plus 1 over resistance 2 plus 1 over resistance 3 and so on, and those will be equal to 1 over total resistance of the circuit. For example, let's take a look at this circuit. You can see that this circuit has 4 resistors and there are 10 ohms, 20 ohms, 30 ohms and 40 ohms. Now, we can put these values in the formula. We will get 1 over 10 plus 1 over 20 plus 1 over 30 plus 1 over 40. We plus all these numbers and it will be equal to around 4.8 ohms. And now we know that this circuit has a total resistance of 4.8 ohms. Now, since the topic we talk about in this video is about electrostatic, I'm going to give you some examples of it. For the first example, you may find it the most obvious and the most common one that you may see every day. It is when the plastic shocks your hand when you touch or put your hand close to it. Or this one, the second example, when you rub a balloon on your head and after a while, your hair will stand up because the balloon attracts it. And now for the third and last example,
You may find this one familiar with you because it appears in many cartoons. It is when you open a box or package and it is full of styrofoams that come in to cushion the package, and then a cat jumps in the box, and then when it gets out, there are styrofoams that stick to its body all over. This happens in a similar way as the balloon that attracts your hair. And the next thing that I'm gonna talk about is quite interesting. It is how the change of temperature can affect the static electricity. First of all, you may often notice that when the weather is cold and dry, you can get the electric shocks really easy when you are touching metal objects like doorknobs. However, it is the opposite when the air is warm. This is because in cold air there is less humidity, meaning that there will be less water vapor to carry the charges away, and for the hot air, vice versa. Now let's go back to talk about the circuit, shall we? You probably have heard of the term short circuits for many times, but do you know what it actually is? If you don't worry, it's fine because I'm going to explain it to you right now. A short circuit occurs when the circuit allows the current to flow to the path that it wasn't intended to go with little to no resistance. Short circuiting can occur for many reasons, including poor quality insulation, which can let the current flow to the neutral wire. Or another common reason is a wire is touching another wire, which can let the current flows to the wrong path. The result of a short circuit can be damaging the device or nearby structure, electrical shocks, or even the start of fire. However, you can prevent this from happening by checking the outlets and device or appliance before using them, and make sure that your circuit breaker is still in a good condition. Well, we pretty much covered all the basics of electricity and electrostatic, and as you all know, physics is a really wide branch of subject, and there are much more you can learn about electricity, like electric field, polarization, electromagnetic, etc. All of these topics I mentioned are really interesting to learn, and we cannot cover them all in one video. So that's it for today, guys. Thanks for watching our video. Goodbye.